when you bring the cost down to be lower than the utility, significantly lower, and you add more power, it changes the total economics. That's why we have a multi-billion-dollar pipeline. The total market is so huge. Just fleet electrification and building electrification combined, it will have a huge effect on those industries. If you don't love what you're doing, then go find something that you will, because you have to absolutely excel at it. And I took his words to heart, and I decided to fall in love with power electronics and controls and creating cool products.
Hey everyone, quick note for you. You're currently listening to the free preview of this episode. If you'd like the full thing, the full shebang, go over to our Substack. That's cleantechies.substack.com/subscribe and become a paid subscriber. Any paid subscription gets you full access to the show on the CleanTechies Substack. Hey everyone, welcome back to the CleanTechies podcast, the #1 podcast for ClimateTech entrepreneurs. I'm Silas Maynor, and today I will be your host. If you're not already, please go and subscribe to our YouTube channel. If you're a fan of this work and are not already a paid supporter, this is also a really great way for you to help us out. If you don't want to upgrade to paid, at least give us that 10 seconds by subscribing to YouTube. It'll help us get one step closer to being monetized. Okay, today we are speaking with Michael Wood and Haroon Inam from DG Matrix, and they are building the future of power with solid-state transformers. Now, what does that mean? In essence, it's a smart software-driven device that replaces old bulky grid hardware. And think of it this way. Instead of using kind of this bulky transformers and coils of wire to power down or power up the voltage, they have a system that can regulate the flow of electricity in and out for many use cases. This is done using a computer chip and software. It also takes up way less space, which is a very huge advantage, especially when you're working in tight spaces, which is not always the case. But even if you have lots of space, who wants to take up 3 parking spaces of transformers just for a few EV chargers when you can use this kind of a little pedestal type thing that they have? It's very sleek, to be honest with you. So as we add more and more electronic devices to the grid, you can imagine this is a very good solution that fits any use case rather than having a transformer for a case-by-case basis. They are backed by ABB, Chevron, and Clean Energy Ventures, and they've already secured a $1 billion pipeline. Yes, you heard that right. They've already secured a $1 billion pipeline. And also shout out to our friends at Clean Energy Ventures as well. We've had them on the podcast as well. So today we actually get a chance to walk through their story and a lot of the lessons that they have learned. Haroon has many things to bring to the table. They've achieved some amazing things in a very short time. So any CleanTech entrepreneur is going to be able to find a lot of different takeaways in how that they can apply to how they're building. We're not going to go through topic by topic what we discussed because it's a lot, but I'm sure you will enjoy the episode. So without any further delay, enjoy. All right, everybody, welcome to the show. How are you doing today, Haroon?
Excellent. Very good. Better now.
Very good. We're also here with our good friend, Michael Wood. How are you doing today, Michael?
Good to see you, Silas. Good to be on this side of the mic for a change.
Yeah, exactly. Yeah, usually you're the one doing the interviewing, so you get to answer a few questions today. So, all right, let's get straight into it. So, I guess Haroon, you've got a very interesting long career doing many different things. But can you kind of pack into a few sentences the summary of your career right before you got to DG Matrix?
Summary of my career has been developing complex systems and cool products for a variety of industries, mostly focused on clean tech, what is now called clean tech, and power electronics.
How did you get interested in clean tech in the first place? Because if you've been doing this for a while, that means you were kind of ahead of the curve, it seems like.
Well, the interesting thing is, it goes back to my days as an undergraduate at Duke. And I was thinking, man, these are tough days on how to find a job and how am I going to get a job? So I decided I'll go to grad school. And I asked advice from my friends, what should I go to grad school in? And they said, well, if you've got a brain, go into software and digital logic. But if you just don't have any brain, can't think creatively, go into power electronics. Because Duke has one of the best programs in the world, but nobody ever does anything new in it. So I love the professor. He's a world famous guy, Dr. Wilson. And I talked with him and I just loved learning from him. And that's how I got a grad degree from Duke under Dr. Wilson. And I used to think, oh man, how did I get stuck in this? And then as time grew and my experience grew, I got lucky. I was standing there with a 35 year skill set right when the biggest change in the market came. and we're looking at a multi-generational opportunity where we're going through electrification now, like we did through industrialization 150 years ago. So, Silas, in one word, luck.
Did it feel really boring in the power electronic space for many years until recently, or what? What was it like at the beginning?
I think I listened to what Dr. Wilson said. He basically said, hey, if you don't love what you're doing, then go find something that you will, because you have to absolutely excel at it. And I took his words to heart one day during a feedback session. And I decided to fall in love with power electronics and controls and creating cool products. And you know what? I have never worked a day in my life. To me, it
Right.
is an adventure every single day to get up and say, man, I'm doing what I love.
Yeah, that's amazing. I think I just want to highlight this for people who, I think, especially people early on in their career, they want some action. They want to make a big impact, especially young people right now. But in a lot of cases, it takes a bit of compounding of your experience in a space to then be in the right place at the right time to really genuinely make an impact, because now you have the kind of know-how to do so. And this is, I think, a really important case with your career in general, is that you were there compounding your network and your understanding of the space until you can make a really big impact with DG Matrix. So before we get into the technology and stuff, I do want to ask Michael to give a bit of an intro as well, kind of what you're working on and how did you get involved with DG Matrix?
Yeah, absolutely. So started off at Duke University, and very key part of what I was doing there was building a platform called Energy Terminal, which started off as a podcast and how we met. And that kind of grew into helping companies with talent acquisition in the energy space. And through that, I met Haroon. And to make a long story very short, I was supposed to go do a different job. And Haroon said, hey, I'm starting this new thing. We're going to call it DG Matrix. And why don't you come do this with me? So been at DG Matrix over a year and a half now. I'm currently working as chief of staff and helping Haroon on whatever needs to get done. And let me just tell you, it has been an exciting ride, and I'm sure we'll get into all the reasons why it has been so exciting later in this episode.
Absolutely. So for other people who didn't catch that, make sure you check out Michael's podcast as well. You said Energy Terminal, correct?
That's right.
Yeah, exactly. So go check it out if you want to hear some really good. He's got some great interviews on there, so check that out. So, all right, now let's talk about DG Matrix. What exactly is DG Matrix, and what is the technology? I think Haroon, if you want to take this one for us, give us a bit of a summary here.
DG Matrix is the first company to develop, I would say, and commercialize a solid state transformer with multiple ports, where each one of these ports can be an input or output on the fly, and any port can be AC or DC or any combination thereof. So we're able to use this multi-port device to our advantage by mixing AC and DC sources with the grid to alleviate grid constraints. And where that comes in very handy today is in the massive market of fleet and building electrification, and the even larger market for Gen AI data centers.
Interesting. Okay. So can you tell us what exactly is a solid state transformer? Tell it to me like I'm 5.
Sure, there are legacy devices that have been around for 100 plus years on the grid that take a voltage and convert it to a different level voltage, all AC. A solid state transformer, however that name comes, really means a device with electronics around it and a very, very small high frequency transformer that does the same job. And our addition to that is that we add ports. And so we make the transformer aspect of it very, very small. And by having electronic ports around it, we can chop up AC or DC to combine it in very unique ways and come up with a far better property set for this than with legacy transformers.
So in maybe if I got this right, is that legacy transformers are kind of mechanically powering up or down the electricity, and then this is like almost like a digital version where it's using different like electronics to change that with a much smaller footprint. Is that accurate?
You could say that, although I think maybe just a slight twist. I would call it electromagnetically powered up,
Mhm.
and in this case, it's electronic plus very high frequency electromagnetic coupling.
Okay, got it. Yeah, I am definitely not an electrical engineer. I work around this stuff a lot, but I always need a little bit of help figuring out the tech. So
You did really well. I think you did fantastic, better than I could have done. It's just that You want to make sure that the general audience is satisfied and the PhDs don't puke over it. So that's why I put
Exactly.
in
That's a good one.
You know that feeling when you meet someone who shares your vision for the future? It just clicks, like two peas in a pod. Well, that's exactly how we felt when we met Goodwin, who we are proud to have as our sponsor.
Being the first major law firm to set up a climate-specific startup and venture practice makes them exactly the kind of partner we are excited to work with. They realize that there are a plethora of challenges to building climate tech startups, and that's why they have built an entire suite of resources for founders, investors, and entrepreneurs in the space. They even offer several tailored pricing methods. And guess what? It doesn't matter where you are listening to this. Goodwin is a global law firm that you can trust to be your partner through it all, from incorporation to exit. They've got you covered.
Go to goodwinlaw.com and tell them CleanTechies sent you to get exclusive access to startup resources. All right, back to the show.
I need to use that line. I'm definitely going to steal that. Okay, so you guys are making this. Now, can you explain, like, I guess before we get into the problem you're solving, where is DG Matrix today in terms of scale, what you've been able to do in the market?
Well, we just completed a few weeks ago a seed round for $20 million led by Clean Energy Ventures with participation from ABB, which is one of the largest companies, if not the largest, in global electrification. Chevron Technology Ventures, the oil and gas company behind it, and Cerberus, which is a $65 billion Wall Street investment firm. And then a family office, Piedmont in North Carolina, super well connected. So that $20 million round now gives us the firepower to put out pilots all over the United States, complete our certification, and start shipping product. So we are about 2 weeks away from shipping our first second generation pilots, and we're about 3 to 4 months away from UL and safety certifications.
Okay, got it. So that's helpful for where you guys are now. Now, can you go back up a little bit and explain what is the problem you're solving? Why is a solid state transformer better than the alternative?
I think a solid state, there have been many companies, and you may ask this in your podcast as well, that have failed to deliver the promise of solid state transformers. One of the epiphanies that my co-founder taught me and realized early on, that if you are just trying to duplicate the work of iron workhorse, the regular transformer, you're never going to be able to do as good a job in terms of reliability, in terms of simplicity, in terms of the ubiquitous nature all around the world. But when you combine functionality and you do extra power processing, then nothing beats a solid state transformer. So that's why we say if it's AC to AC, sure, we can do it. But where we excel is when there's multiple ACs and multiple DCs to combine. And the problem set, that's a huge market to solve, is wherever there is a shortage of power on the distribution feeder, or it's going to take a far longer time for the utility to get there, or you have a cheaper cost with our combination of renewable energy, including fuel cells, solar, batteries, etc. That's where it makes the most sense.
Hey founders, if you're hiring, I've got a special offer for you. For those of you who do not know, to pay the bills, I run a search firm called ErthTech Talent. That's Earth with no A. We specialize in placing top sales and engineering talent at early stage clean tech startups in the United States. And we do it for way, way less than traditional search firms. I've actually been working as a recruiter for over 5 years in clean tech and have made over 70 placements, from the CTO of Aypa Power, a Blackstone-backed energy developer, to most of the founding team at ChargeScape, a managed charging software joint venture between Honda, Ford, BMW, and Nissan. Early stage clean tech startups can't afford to not have the right talent, but they also cannot afford to use a traditional search firm for their recruiting needs. That's where we can help. We charge as low as 12% of first-year base salary, and this is compared to the typical 20 to 30% that most firms charge. So you can get an expert in the space at a price that does not break the bank. If you'd like to learn more, check out our website, earthtechtalent.com. That's, again, Earth with no A. And we really value transparency, so our pricing is publicly available on the website. If you're looking for support, book a call today. My calendar link is in the description, and be sure to reference this ad for $1,000 off of your first search. All right, back to the show. Okay, interesting. So, in other words, if you're just powering up or powering down for one use case, it may not be the best because engineers are more comfortable using kind of conventional technology. But when you've got kind of, let's say, multiple inputs or outputs in different types of frequencies, your solution is substantially like better.
Hands down. I
Yep.
mean, yeah, right. Frequencies or voltage levels or
Mhm.
AC or DC combination and sources and loads. Exactly like you said. So then we excel. We eliminate about 11 to 20 different components in that infrastructure when you have those multiple sources, and we combine it in one monolithic solution. That is an astounding improvement in terms of installation cost, in terms of the footprint that we take up, in terms of the commissioning, in terms of reliability. And sure enough, it is a significant cost savings in CapEx. It is a OpEx savings because the efficiency is higher. And it's far more reliable to have one device work well rather than 11 to 20.
Interesting. I wasn't going to ask this right away, but I think it makes sense right now because you mentioned it. If there is such a CapEx savings, does this fundamentally change the economics for certain renewables projects?
I think for us, when we look at it between 200 kilowatts and a handful of megawatts, it absolutely changes the economics because that has been an underserved segment in the commercial and industrial world. The engineering cost, procurement, commissioning, the installation cost have made the levelized cost of energy or the cost per kilowatt hour to be much higher than the utility in most cases. So people don't gravitate towards this. It's a very small market. But when you bring the cost down to be lower than the utility, significantly lower, and you add more power, it changes the total economics. That's why we have a multi-billion dollar pipeline, a billion to billion and a half dollar MOU for infrastructure, as well as significant interest from data centers. And it's all about economics. It is not driven by government incentives at all. It's driven by pure economics of supplying energy.
That's amazing. I mean, $1 billion pipeline is definitely, let's call it product market fit on steroids, right? It looks like that's working. Now, tell us a little bit about how you make money. So you're not developing projects, correct? You're just primarily selling the hardware. Is the objective to sell the hardware to other project developers? Is that right?
Yeah, I would say it is selling the hardware. And however, it's not just the hardware. It's hardware with very, very detailed firmware and then machine software and then cloud-based software. So
Okay.
it's the entire tech stack. And
Mhm.
yes, in the beginning, the price is more like selling a hardware piece with some software licensing. And over time, we hope to increase the software licensing mix and lower the upfront hardware
I
cost.
see. Okay, interesting. Okay, that's very helpful. So, how did you end up, I guess, coming to found this company, or co-found this company, I should say? What's the story there?
Well, one day, Dr. Bhattacharya, my co-founder, and I were on a car trip, and it was a 5-hour car trip to the DC area. And we basically started thinking about what was happening in our careers. And he started to bring up a device that he was having some issues with on how to apply it in the market. And over that 4 or 5 hour trip, we went through some very high speed conversations. And that's when the idea for DG Matrix was born, that we could take improvements upon things that he'd done, add significant IP to it, and hit potentially multiple markets with it at the same time. And on the way back, the next day, after we had completed our visit, we started calling people and getting some metrics together and started to formulate a team. So yeah, it just came together very quickly in a couple of car trips.
ClimateTech founders are taking on a huge challenge. Not only do they need to know how to build a startup, but they also need to deal with hardware, have a strong handle on climate policy, know how to fundraise from diverse investor types. It's a lot.
That's why we made CleanTechies, the #1 podcast for climate tech entrepreneurs. In addition to our jobs, we devote 20 hours a week to producing this podcast for you. This way you can learn from the people who have walked the path before you, learn from their mistakes, and gain insights on navigating this complex journey. If this mission resonates with you, we are asking for your help. It takes a lot of effort and it's not free.
If you are already a subscriber and want to help, Start supporting us today by going to Substack and clicking Upgrade to Paid. Thanks for helping all the ClimateTech entrepreneurs like you. Interesting. So can you talk more about like the nuances there, like actually getting this thing going? So what were you doing at the time? Like, did you have to wind things down? What really made you say, listen, like we're going to go do this? And how did you fund it at the beginning, et cetera?
Well, we basically, I helped fund the company from my savings. And I was an early investor, right? I was working at another place, and so I had to transition out. But I was an investor, and I helped pull this together for DG Matrix. And then later on, as I parted ways with my then employer, I became involved full time in DG Matrix and was appointed CEO. And that's how DG Matrix then started to go at a different pace.
What is the process that you go through at the very beginning of something like this? Because it's an idea, you have an understanding as to, this could work hypothetically, and we have an idea. But how do you then take it forward enough to then be able to bring in outside investors? Like, what are those key steps along the way to making it? Now that you have $1 billion pipeline and you just raised a $20 million seed,
it's a roller coaster ride. It's a multi-phase roller coaster ride because you're trying to figure out, can I really get this to work? And is there a market? Probably the best simple book to read is The Lean Startup, which is, 10, 15 years old. But it describes on the XY plane the commercial and technical iterations you must go through to see if your product has a fit or not. So essentially we did that while simultaneously assessing the talent, the infrastructure, the money, the timelines, the intellectual property, the patents, the barriers we would have to overcome. And that's how we said, nope, let's stick with the lean startup methodology, but bake in what are traditional stage gates in corporate product development so we don't miss anything.
Okay, got it. And I'm always curious, in the early days, who are from looking back, who are the core people aside from your co-founder that really played an important role in helping DG Matrix to get to where it is today? Maybe some particular outside investors or some influence that was able to really elevate your profile in the market, if you will.
Absolutely. We reached out to our mentors and our friends who had been CEOs of $1 billion+ companies in the clean tech space before it was called CleanTech. One of them was Jan. He came with a Siemens pedigree. He had been a partner at Kleiner Perkins. One was Mark. He had been CEO of Powerware before it was sold to Eaton. One was Alan. He was CEO of multiple ABB groups. And we reached out to these guys. One was Dr. Wedding at Duke University, a professor in clean tech. And one was a very high-level partner in clean tech at McKinsey. So we put together this team of advisors, and they helped us. They opened doors, and they advised us on hundreds of strategy questions that we needed to answer. And that senior level CEO experience, multiple decades of it, that's what helped us formulate the ideas faster.
Mm-hmm. Yeah, I just want to kind of like re-highlight what you just said there for the listeners, that you were able to build an amazing book of advisors, if you will, that were probably able to accelerate you far past what you would have done on your own. Like if you were just doing this on your own, asking questions and failing along the way, it might have taken you, 2 to 3 times longer to achieve the outcome, but people kind of guided you on what to look out for. And the other thing I'll highlight is that you had, like you said, people from Siemens, people from ABB, people who had been in the conventional industry that you're kind of, I guess you could say, competing with in some way, or solving some of their problems. They had insights that could offer you, and I think many ClimateTech founders could take note of this to do themselves as well. So I wanted to highlight that for people. So
could I say something?
Yeah, of course.
Absolutely. I would say 2 things. Every single CEO we chose of the multi-billion-dollar company or partner or professor had done both big companies and startups. Mm-hmm. Because if you only do one, you don't get the other perspective, and you need to do both. So that was lucky that we had that sort of a Rolodex to go pull. The second thing I'll highlight is even more important, and that is no matter how much passion and how much energy you have, humility must be your number one characteristic, or you're not going to be able to listen to these high-powered people who are going to give you frank feedback. I mean, they have 100 things to do with their time, so they're not going to sugarcoat everything. And if you take it personally, then you're not going to grow. So my suggestion is listen, learn to listen, and then you listen to learn. And that's what we did.
No, that's amazing advice. I love that. So my limited understanding of this market is that this, like the basic technology itself, has kind of been around for a little bit of a while. You mentioned you guys have some iterations on it, but my question is, and there's been my understanding is there's several companies who have really failed at trying to achieve this. So why, like, what makes DG Matrix different? What is the secret sauce here that's going to allow you to succeed compared to the others who have tried?
That is an excellent question. So I think the first thing I would say is it's the market fit. We're getting lucky on the market timing and the product market fit. The fact that we're doing multiple AC/DC inputs and outputs together with the right market timing, that's why. Number two, we have simplified the circuitry of this multi-port solid state transformer way above what anybody else has done on previous SSTs. And number three, I think we have an incredible team of very talented people in their domains, and it's a multidisciplinary product development team. We pretty much had to develop every single key thing ourselves, from the circuitry, the minimized circuitry, from the packaging, the cooling, the controls, the firmware, the aerospace quality firmware that's running in nanoseconds. That level of work, we had to do everything ourselves in order to have a very vertically integrated solution. And simultaneously, we developed the factory footprint and the supply chain so that when the product got ready, it was ready to hyperscale soon thereafter for very low capex. That's why I think we're going to be ready. We focused on the economics of the product and the lead times, and we focused on the simplicity of the device itself.
So let me make sure I recap this. So you're saying that it was a combination of market timing. There was kind of an appetite for it. Secondly, contrary to what other people have done, you developed everything from scratch. It sounds like you kind of redeveloped the entire tech stack. You didn't just take as many white labeled parts from other people. You redid things yourself, and you had an eye towards the unit economics once you were to go, build a factory. Are those like the three buckets? I got that right?
Those are the three buckets. And of course, I'll add in that Dr. Bhattacharya, my co-founder, having him done a lot of background work throughout his career for 30 years was absolutely instrumental in speeding up that product development roadmap and in de-risking a number of things. And then we are up to 175 engineers now. And without that global group where we did all this work, we poured in before we raised the round 350,000 engineering hours at a cost of under $10 million. You couldn't do this work in the US, but now the US is the headquarters and we're growing our team here. So all of that contributed towards getting us to a point ready to scale. Silas.
Okay, awesome. Well, those are really great insights. I think just, again, not to constantly circle back and highlight these things, but I think founders should really take note of that kind of methodology that you guys followed there. So with the product you have and that you're building, now going to be scaling, what is the impact that you can make if everybody transitions over to using this type of transformer?
I think the market applications are so massive. The total market is so huge. Just fleet electrification and building electrification combined, it will have a huge effect on those industries. You can make building power cheaper. You can kill demand charges. You can enable project finance type of models better. You can help enable FedEx and Amazon and school bus fleet electrification far faster because you can deliver lower, cheaper, or bigger electricity at lower prices. That's one massive market. The other massive market is Gen AI data centers, that we have the technology to not only aggregate sources, but also, more importantly, to provide redundancy and to provide huge surges for learning engine cycles that are needed by the NVIDIA or anybody else's processors. So our technology uniquely has that capability to route those surges to either capacitors or super high cycle batteries. And I think that's another massive impact, helping enable the next level of intelligence for the human species. Those two markets are big enough. Personally, I think this device enables a micro utility anywhere you put it. You could enable a micro utility in remote villages. You could enable a micro utility where people don't have the money to put in $100 million transmission line, and you could change the lives of folks that are otherwise destined to live in energy poverty. Think of the impact you could have globally on those lives, right? At a far lower economic cost. Think of how many more geniuses you could enable and how many lives you could help uplift with this tech. So sure, great for the developed world, but also great for the developing world.
Mm-hmm.
That's the human side of where our passion comes from.
Yeah, I mean, it makes sense because what you're effectively saying is that, if I understand this correctly, with right now we have a huge increasing demand on, like, let's talk about the US grid, right? A huge increasing demand, especially with AI and data centers. But even though we're not going to be able to probably build out that energy as fast as we need to, through this technology, we can still basically serve a lot of that demand without having built out all of the energy supply. Is that accurate?
It's very accurate. Not only energy supply, you're not going to build 10 nuclear plants in the next 5 years. So certainly that, and you can do it right where it's needed with incremental investment rather than a massive investment in something that might not work out.
Yeah. Okay. And now one other thing I want to ask here is I don't know if this is accurate. So maybe, and this question is for either of you guys, but my understanding is that the wait times for transformers is like very, very massive. Is the idea here that you can probably solve that a lot faster if once you guys get your manufacturing up in line, like this will not be the case anymore for these wait times to be able to install these transformers?
Yeah, I think we are on that roadmap. We're on that path as well. We're trying to eliminate the next line transformer, the medium voltage transformer that connects to the grid. And we have done this sort of work for 10, 15 years in different places, both my co-founder and I. So it's not a matter of de-risking the technology. It's a matter of at what speed can we get there. And certainly having standard product and standard building blocks that apply to a significant number of markets, we can reduce that lead time, not only because we have done the supply chain engineering upfront, but because we use far, far less material than anybody else.
What does it mean to do the supply chain engineering upfront?
Well, for example, we started and I asked engineers, do you have a bill of material for the control board, one of the boards that goes in? So as we looked at it, we saw, wow, to get this part is a 1-year lead time. So how did you choose this part? Well, I don't know. It seemed like a good part. What's going to be a year? It's a year to get it if you want it in any volume. So can you engineer it out? They're like, oh yeah, that's pretty simple. Why didn't you ask before? So that sort of homework needs to go in when you're professionally designing a company to hyperscale. And so they brought down the lead time from a year down to a couple of weeks, 4 weeks, 5 weeks. And then we work with pertinent suppliers to keep it that way. What this does is it allows you to respond far quicker. And it also allows you to have far less working capital needs when you ramp up because you don't have to tie up that much inventory for that long. And that's supply chain engineering, plus looking at the finances of the right suppliers, make sure you're not going with some company that might not survive. There's a lot of considerations that go into developing and selecting and developing the supply chain. And we did a whole bunch of that homework up front.
Yeah, those are definitely some golden nuggets there. I don't think I've ever asked that question before. I should probably get more into the weeds like this more frequently on the show.
It's not just the lead time for the transformer, but the bigger thing is that the utility upgrade is the real lead time that we're compressing. A utility, if you install solar or you install batteries or you look for a utility upgrade on the feeder to get you more power, that's arguably 2 to 5 years per our customers' feedback. So we can get in there in 6 months behind the meter with the simplest possible permitting and get you power that's far cheaper. That's the real reason that we're creating a huge pipeline.
Yeah. Okay. That makes sense. So on that topic of pipeline, then what is the, I guess you could say, lessons or tactics people could use on their own products that they're doing something similar?
It took us longer to raise money than we had planned. It took a lot more grit than we had assumed. And it took us about 206 no's to get to a point to where there's a yes.
One other thing that I'll add that is very unique about DG Matrix in this regard is because we had, despite the fundraising challenges and the market timing, that time that we were able to take to really get things right, execute pivots, and to understand where our focus is going to be most fruitful in this market, ended up being a very positive experience for us.
Smarter corporate developers take a savvy two-pronged approach, investing in the right company, but also trying it on their own in case we don't make it.
Hey everybody, this is the end of the free version of the episode. If you would like to get the rest of the discussion, you can upgrade to a paid subscription today. The day that this comes out will be the last day to get our annual paid subscription for $80 a year. As of May 1st, we are going to be raising this to $100 a year. So if you'd like to get access to the rest of this discussion, as well as all of our discussions and all of the other bonus content that we could produce, as well as the community that we have, it's $80 a year as of today, or at least if you're listening to this the day it comes out, it's $80. Beyond May 1st, it will be $100 a year. So upgrade today. If you'd like to get the rest of this discussion, if you haven't already found it valuable, I don't know if you weren't listening, but I think it was pretty great. So if you want to get the rest of this, upgrade to pay today. To do that, you just go to cleantechies.substack.com/subscribe and pick any tier that works for you. Again, $10 a month or $80 a year. So head on over, and today, or I should say, May 1st is when the prices are going up. So don't wait around. All right. Thank you guys so much for tuning in, and hopefully we'll see you on the other side.